Okay, so what is the highest common factor? Let us consider one example. Okay, let's see an example. Okay, so let's consider the factors of 18 and 24. Okay, so 18. So 18 we have 1 times 18, right? Then we have 2 times 9, right? We have 3 times 6, right? So this is the factors of 18. So we have 1, we have 2, we have 3, we have 6, we have 9, we have 18, right? Okay, how about 24? 24, we have 1 times 24. So we have 2 times 12, right? So we have 3 times 8, right? What else? Do we have 4? 4 times 6, right? Any more? Not right. So how many factors we have? We have 1, we have 2, we have 3, we have 4, we have 6, we have 8, we have 12, some more, 24 itself, right? Okay, so from here we can see that, right? Okay, we can find out something, right? Okay, so we can see. So we can see 1, 2, 3, and 6, right? 1, 2, 3, 6, right? Okay, so the other common factor of 18 and 24, right? Is it correct? Just look at here. Right. Okay, so they are the common factors. The common factors of 18 and 24. Okay, so let's consider explore. Okay, inside this 1, 2, 3, 4. So 6 is the what? 6 is the largest. Okay, is the largest common factor. Okay, 6 is the largest common factor. Okay, so in this case, we call the 6 is the highest common factor of these two numbers. Okay, 18 and 24. So we give a name, right? Okay, so 6. So therefore, 6 is the highest common factor, or we call HCF of 18 and 24. Okay, let's remember this. Okay, now we give the definition for this highest common factor, HCF. Okay, how we call that? We call that is the highest common factor, HCF of two or more positive whole numbers is the largest positive integer that divides the numbers without a remainder. Okay, without a remainder. So in this case, 6 is the highest common factor, HCF of these two numbers, 18 and 24. Okay. Sometimes we also call the highest common factor. We have another name. It's also known as the greatest common divisor. Okay, greatest common divisor. Okay, or GCD. Okay, sometimes we also call this name. Okay, just remember this. Okay, so in this case, okay, so now we know the definition of these highest common factors. Okay, let's move on to say, okay, so how to find out next question is how to find out the HCF. So there's many methods, many ways to find out the HCF, highest common factor of the two or more numbers. Okay, we can use, but basically because we already learned how to do the prime factorization, so basically we use the prime factorizations to find their HCF in a more effective way. So we use the prime factorization. So that is the most effective way. Okay. So in this case, we will use the prime factorization. Okay, we'll use this method. Okay, to find out the HCF. Okay, because this is one of the most effective way. Okay, now let us give some example, right? Okay, the first example. So find the HCF, the highest common factor of 225 and 750. Okay, so basically, okay, in this case, so basically we have two ways. Just now we see use the prime factorizations to find a way, right? Okay, let's use the first one. Okay. Okay, prime. Okay, so how we use that? Okay, we can use the vector tree, right? Okay, so 2 to 5. How we find 2 to 5? Okay, so we also recall that. Okay, so if a number, so all its digit is a sum of the sum is divisible by 3, so they also can be divided by 3, right? So 2 plus 2 plus 5 equal to 9, right? So in this case here, can we put 3? Then we get a result what? 7 and 5, right? The next one is what? Can we put a 5? Can we put another? Okay, we'll put another 3. So 2, 5, right? So continue. 5 and then 5. Okay, so what is the prime factor for this? 2 to 5, 2 to 5 equals to 3 times 3 times 5 times 5. So we got this 3 square plus 5 square, right? Okay, let's continue another one. So okay, so another one is the second one is the same thing, factor 3. Okay, so same thing. Okay, so is that divided by 3, right? 3 as well, right? So 3, okay, much 2, 5, 0, right? Okay, next one. Is it divided by 5 as well? Can we divide by 2? Or maybe we put 10, 25. Got 2 here, we got 5 here, we got 5 and 5. So in this case, let's divide by this 2. Okay. So in this case, how much we get? 750 equals to what? Equals to 2 times 3 times 5 times 5 times 5, right? 2 here, 3 here, and 3 5s here. Okay, so we get how much? 2 times 3 times 5 square. Okay, so let's compare these two. Okay, let's put them together. Okay, how to put them together? Let's put them together to visualize how can we compare these things. So okay, maybe we can put them together. 2 to 5 equals to 3 times 3 just compare these two. Okay, so let's remove it. Okay, so in this case, how many common factors they have? So we have 3, we have 5, we have 5, right? So these two count, we don't have this common. So in this case, so what is the common? Therefore, the highest common factor is 3 times 5 times 5 equal to how much? Is that 75? Okay, and we also notice that, okay, so it's 3 times 5 square. Okay, because here you got 5, right? Okay, so here we can see that, okay, so basically in this case, okay, so the HCF is able to obtain by multiplying the lowest power, okay. For instance, this number, so in the tree, the lowest power is 1, right? 1, okay? And then this 5, the lowest power is 2. It's 2 here, right? It's a 2 here, right? So the lowest power of each common prime factors, which is 3 and 5. So that's of the given two numbers. So in this case, surely, okay, we'll see here the lowest power, the common factor, this is 2, the 3, 750 have 3, right? 225 have a 3 as well. What's the lowest power? The lowest power is 1, so we take the 1. Okay, so for 5 is the common factor. So 5, what's the lowest power? The lowest power is 2, right? In this case, we take 2. Okay, so we also can get a result is 75. Okay, is that clear? Right? Okay. Basically, okay, we also have an alternative method to resolve this question. Okay, now here we're using the prime factorizations based on the factor trees. We can resolve this question, right? So now we use the alternative method. Okay, let's look at how to resolve in the alternative method. So what is the alternative method? Alternative method. Okay. Successive short successive division. Okay. So how we do? Okay. We'll put these two together. 225 and 750. Okay. So what we get? So can we put the common? So basically, all of factors, all of digits, out of the, this is 9, this is 12. Okay, so in this we can put 3, right? How much we get? 7, 5, right? So this one 2, 7, 0, right? Sorry, 2, 2. How much we get? This is 2, 6, 1, 5. Okay, 5, 0, right? Okay, here, how about here? 5, right? What we get? We'll get 1, 3, 1. This is the 1, 5, 25, 5. Here, how much we get? 5, 50, right? So another 5. Here is how much? It's a 3. And how about this one? So it's 10, right? So it's no more already. Okay, there's no common factor. So in this case, the HCF equals to what? The common factors. We just multiply all the common factors. So together, in this case, the HCF is the product of all the divisors. Okay, it's product of all the divisors. In this case, is what? 3 times 5 times 5 equals to 75. We get the same answer, right? Okay, this is the alternative method. Okay, that's good, right? Okay, so let's move on to the next example. Okay, so same thing. So we have these two, right? So basically, we use the first one. Okay, so we use the prime factorization. Okay, again we use factor tree, right? 2, 5, 2. Okay, so what we get? So this one add up together. 2 plus 5 plus 2 equals to what? This is how much? This is 7, 7 is 9, right? Okay, 3 digits add up together is divisible by 3, so then the whole number be divisible by 3, right? 3. Here, how much we get? What do we get? This is 7, right? Not 7. Okay, so this is 8, 24, right? 12 is a 4, right? Next one. Can we move to 2? 2, this is how much? 4 and 2, right? This one? we have a 6 and 7, right? Here, can we divide by 2 and 3, right? Okay, so how much we get? So 252 equals to 2 times 2 times 3 times 3 times 7, right? Is that correct? 2237. Okay, let's look at the other number. Let's look at the other number. 360, right? Can we divide by 3 in this case? Yes, right? So can we divide by 3? So what we get here? 1, 2, 0, right? Here, what you get? Can we divide by 2? 60, right? 2, 30, right? 3, 10. Okay, is that correct? Good. Okay, so what's for this 360 equals to how many? 2. We have 1, 2, 3. 1, 2, 3 times 3. 1, 2, 2, right? Five. Okay, is that correct? That's good. Okay, so in this case, can we move them together? We move them together. Okay, so just right here. So here's 2 times 3 times 7. So what we get here? We get 2, 3 times 3, 2 times 5. Okay, so just so we understand that, okay, so HCF is able to obtain by multiplying the lowest power of the common factors. Okay, so in this case, so what is lowest common? Lowest common factors. Okay, we have 2. We have 2. 2, the lower is 3, right? Then times the lower is 2 square here. Okay. Okay. 3, how about 3? 3 is the same. 5 we don't have. So what the number we have? We got 4 times 9, 36, right? Okay. So this is the one. Okay, we use the lowest power of each common prime factor. Each common prime factor. Lowest, right? Okay, so of course we also can visualize the process rather than should we go to this thing. We can compare these two, right? We still can compare these two. Okay, let's compare these two. 2, 5, 2 equals to 2 times 2 times 3 times 7 times. Okay. Okay, let's see. The HCF equals to what? 2, yes. 2, yes. 3, yes. Okay, so 2 here times 2, another 3 times 3. Same thing, right? We get same answer, right? Okay, very good. Okay, let's look at this one more way. Okay, the other way to resolve these things, we use the alternative method. Okay, let's try the alternative method for this question. Let's try the alternative method. So what is the alternative method? Okay, the alternative method, we call it is the successive short division, right? Okay, do you understand that? Do you remember that? So we put these two numbers together. 252, 360. Apparently, yeah. 3 can be used to divide these two together. So in this case, it's 3. So we get 8 right here. Then balance 12, 12 is 4, right? Here apparently is 2, 8, 0, okay? Can we use the 3 again? Yes, right? So, what do we get here? Can we put 2, 4? No, so 2 is 6, 6 is 24, 24 is 8, right? Okay, next one is what? This is 40, right? Okay, so in this case, how about it? We can divide by 2. Yes, right? 14, right? 14, 20. The other 2, 7, 10. Okay, there's no more already. So in this case, okay, let's recall that. Okay, let's recall that. Let's recall the idea. Okay, let's recall the idea. HCF equals to what? Product of all the devices. Okay, in this case, what is the HCF? The highest common factor. So we just add up all this together, right? 3 times 3 times 2 times 2, right? Then we get answer. 9 plus 4, 36. Right, okay, we got the same answer, right? Okay, very good. Okay, let's move on to next question. Okay, 3 numbers. Same thing. Okay, we have to go into use the keyboard tree. Just a quick one, very fast one. Okay, 84. So what we get? We get 2. We get 4, 2, right? Then we get 6 and 7, right? So we have 2 and 3, right? So then we get answer 48. We have 2 times 2 times 3 times 7. Okay, right? The next one. How about this 1, 2, 6? What do we get? Can we divide by 2? Yes. Okay, so what we get here? What we get here? 6, right? 3, right? Okay, next one what we get? Can you divide by 3? Yes. 3, 2, 1, right? Next one. So can we get 3, 7? Okay, very good. We just try to divide it. Try to divide this thing. Okay. Try to divide this thing. Okay. Let's try to divide this thing. Okay. So what do we get? 1, 2, 6 equals to 2 times 3 times 3 times 7. Right, okay, then we have this one. 2, 4, 5. What do we get? Okay, can we divide by 5? Yes, can we try 5? Yeah, we can try 5. 5, what do we get? 5, what do we get? We get this 4, right? 20, 48. So it's 49, right? Continue. 7 and 7, right? So 2, 4, 5 equals to 5 times 7 times 7. Okay, so that's what we get. So how? Okay, let's put them together. Let's put them together. We put here, put here. Okay, let's put them together. So, okay, in this case, what's the common factor? What's the common factor? Okay, the common factor is 7, right? 7, right? Okay, so can we see that the highest common factor is 7, right? So 7 is the answer, right, for these 2 numbers. Okay, for these 3 numbers, 1, 2, 3, right? Okay, so can we use another method? So the highest common, the lowest power of, so this is 3 squared times 3 times 7. This is 2 times 3 squared times 7. This is 5 times 7. So basically, the lowest power of each common factor is 7. Again, the answer is 7, right? Okay, we can see that. 7 is the only common factor, and 7, the lowest power of this common factor is 1. It's a 1 here, right? So then we get this 7 also. Okay, Ken. Let's quickly use the alternative method. to find out the HCF. We use the short successive divisions, right? The alternative method, right? Okay, how we use the alternative method? Okay, let's see. How can we use it? How can we use it? 84, 126, 245. So what's the common factor? The common factor is only one, right? There's only one common factor, it's a 7. What do we get here? 114, 2, right? Here we get how much? 1, 7 feet. It's 18, right? Sorry. What do we get? What do we get? 1 is 59, 56. So it's 8, right? So what's here? 3, 21 is 21, 5, right? Okay, so here's, say is the product of all the divisors. Okay, in this case the divisors only 7. Okay, we get answer 7. Okay, it's good, right? Okay, so straightforward, right? Okay, let's try another. Okay, let's look at the next example. Let's look at the next example. Okay, very good, right? Let's look at the next example. Okay, next example is it's 154, 330, and 396. Okay, so same thing. Okay, so how are we gonna do? Okay, so same thing. Okay, very quickly. 1, 5, 4. Okay, let's draw the line first. Let's draw the line first. Okay, let's draw the line first. Okay, so this one, what we get? Can we divide by 2? Or we'll try the 2 first, right? It's 2, right? Okay, how about here? 2 becomes 7 and 7, right? Okay, let's continue. Here 7, here 11. Okay, that's all. So 1, 5. So we get 2 times 7 times 11. Okay, that's where we finish. Okay, let's look at the next number. What we get? 330, right? So apparently we can divide by 3, right? Okay, let's divide by 3. So we get 110, right? And we can divide by 2 apparently. So it's a 5. It's a 5, right? The next one is 5 and 11. So what's the answer? 330 equals to 2 times 3 times 5 times 11. Okay, let's look at the next one. 396. Apparently you can divide by 3, right? Okay, let's put by 3, put the 3 here. So what is this number? So 132, right? Okay. What can we divide by 2? We try the 2. So we get 6, right? 6 and 6, right? So here 6, 11, 2 and 3. Okay, so what's the answer? 396 equals to, we have 2, 2, right? We have 3, 2, 3, right? We have 11. Okay, just look at here. So what's the common factor? Okay, you can put them together, no issue. Okay, let's look at here. So what we can write in the index notation. Here nothing, here nothing. Okay, so now we write this way first. Okay, so in this case, so everyone have 2? Does everyone have 2? Yes, we have 2, right? 2 and 2. Okay, everyone have 7? 7? No. Okay, everyone have 5? No, 5. Okay, everyone have 11? Yes, everyone have 11. Okay, that's good. Okay, so in this case, HCF equals to 2 times 11, right? 22. Okay, very good. So in this case, the answer is 22, right? Okay, very clear, right? Okay, so also the, 2 is the lowest power of the common factors is 1. So in this case, everyone is have 1. So in this case, and then we have 11 also is 1. So in this case, we get is 22. Okay, straightforward. Then let's use the prime factorization by this factor tree method. Let's look at the next method. How we use the alternative method to resolve this question. Okay. Okay, the next method. Alternative method, right? Successive short. One five four 330 396, right? Okay, so what do we get? Okay, so can we divide by all numbers divide by 3? Yes, right? Apparently in 3, right? So what we get next? So here is 5. No, we can't divide by 3. 3 is not a common one. So we should look at probably 2. We cannot divide by 3 in this case, because especially here you can see this number. So 1 plus 1 plus 4 is a 10. 10 is not divisible by 3. So because these 3 digits add up together cannot divide by 3. So this whole number cannot divide by 3 as well. So 3 is not possible. So in this case we remove this. Okay. About 5. Okay, because this add up together is the 10. So in this case we can divide by all the 3 digits add up together. It is divisible by 5. So in this case we can divide. We can use. We can use 2, right? We can use 5. Okay, no, here is count. Okay, in this case we'll try 2. We'll try 2 first. Okay, 2. How we get 7? It's 14. Okay, 7. Okay, that's good. Apparently this is okay. So here is the. Can we put 1? 1 becomes 13. 6. Okay. 6 is 12. 12 is 10. 5. Right. Okay. So let's try the next one. Here 1. 19. Put 16. 16 is 8. Okay. So the next one we're gonna put is how much? So can we put it's 11, right? Is it 11? 7 we get. Here how much? We put we put the 1. Can we put 1? 1 we get the 11. 11 is 5. 5. Okay, so it's a 5. Okay, how about here? Can we put the 1 as well? With 1 we put 11. Then we get 88. 88 is 8, right? Okay, is that able to divide? No more, right? Okay, so in this case, very clear. So HCF is the product of all the divisors. Okay, in this method, right? Alternative method. So in this case, is this 2, right? 2 times 11, we get 22. We also get the answer, right? Okay, very good. Okay, let's move on to the next one. Let's move on to the next. Okay, next example is that. Okay, just look at the next example. So a rectangular fuse of 20 meters by 15 meters is divided into identical square plots of the length. Find the largest possible length of the side of each square plot of the length. So in this case we have so basically we have a length. So we have 20 meter, we have 50 meter. Okay, so we have these two. So find the largest possible length of the side of each square. Okay, it's a square, right? Okay, we need to find out this. Okay, so how many numbers of the side of each square cross with the largest possible length? So okay, we're gonna find out this. So the length of them. Okay, so in this case, okay, the length of each side of each square cross of the length should be divided by. If this is the case, so everyone must be each side of this plot should be able to divide by the 20 meters and 15 meters respectively, right? So in this case, so hence we actually finding a common factor. So basically, we are finding a common factor for these two numbers, two lengths. Therefore, the largest possible length for this 20 meter and 15 meter. So basically we are finding the HCF, right? Actually we are finding HCF, the highest common factor of these two numbers. Okay, so in this case that is very clear, right? So okay, okay, we are finding this. So at first let's find out what's the factors for 20 and 15. So 20 equals to, can we use the factor tree as well? It'll be quite straightforward, right? We use the factor trace. Okay, 20, we have 2 apparently, we have 10, right? So the next one is what? The 2 and 5. So 20 equals to 2 times 2 times 5. So how about 15? 15, right? 15 we have 5 apparently, we have the 3. So here we find answer. 15 is the 5 times 3, right? Okay, so in this case, so what is the HCF of these two numbers? So do we have 2 here? Don't have 2 here. Don't have 3 here. Don't have. Okay, so we have 5. We have 5, right? So in this 5 is the 5 meters is the highest common factor of these two. So in this case, so it's 5 meter by 5 meter. Okay, so of these two numbers. Okay, so here we find answer is a 5 meter and 5 meter. In fact, we can draw this. In fact, we can draw this thing here. So so we have we can draw this here. Yeah, in fact, we can draw this thing here. Okay, we can draw this thing here. Okay, something like this. Okay, so we have a tree here. 1, 2, 3. We have 4. 1, 2, 3, 4. Okay, so in this case, here is 5m. Here is 5m. Okay, of course, not to the scale, right? Okay, not to the scale. Okay, not to the scale. Okay, not to the scale. Right? Okay, this is the answer. Okay, let's look at the next example. So next example, just look at the rectangular piece of the paper is 35 cm by 28 cm is cut into obtain identical squares. So find the largest possible length of the side of each of the figure. So basically it's the same thing, right? So we have a paper 35 centimeter and 28 centimeter. So basically you're gonna cut a square. So you need to find out. So what is the largest possible square you get? Okay, for this area, right? So in this case, okay, straightforward. We're looking for the highest common factors for these two numbers. So just use the factor tree. So 28. What we get? We got 2, right? We got 14, right? So we got 2, we got 7, right? How about this 35? 35, can I put the Can we put a 5 here? So we got 7, right? So in this case, 28 equals to 2 times 2 times 7. So how about this one? 35. 35 equals to 5 times 7. Okay, so come. So what is the HCF of these two numbers? Do we have 2 here? Don't have. Do we have 5 here? Don't have. We have 7. We have 7. 7. Cm is the highest common factor. So in this case, you can cut the highest 7 centimeter of this is square. This is square. Okay, so basically you can cut. Okay, we can draw that one. Okay, so basically we can cut to the 4, right? Now we have an answer, right? Over 5 here can 5, right? 1, 2, 3, 4, right? 1, 2, 3, 4, 5. Okay, not to scale. Okay, just for information purpose. So in this case, we can cut here is 7 cm. Here also 7 cm, right? Right? Okay. So this is another example. Okay. So basically, we have listed down all the examples. Okay, related to find out the highest common factor, HCF. Okay. So basically, this is the example to find out the application. Actually, this is one of the application for this HCF in our lives. We have to find out how many squares we can cut on this paper. All right. Thanks.